all, let me, welcome you to National Manufacturing Day and our celebration on the SUNY Polytechnic Institute's campus. My name is Marv Meisner. I'm the Director of Continuing and Professional Education here at SUNY Poly. And this is one of the great pleasures we have is doing this event. So the CPE department kind of takes care of this event, one of the many we do, but it's one of our favorites. And it's an event that, as you've heard or probably already, it just has exploded in popularity. We did this 2 years ago, and we had a very nice little intimate group of 50 people. And last year we decided to get some education folks involved and get students involved, and we went from 50 to 350 people. We thought that was good. Okay, so we decided this year we set our sights a little bit higher, and we said, well, it'd be nice if we get 500 people, 550. At latest count, we've got over 800 here today. And you can see the great turnout we have of our high school students. We're very, very pleased at that. This track is going to be devoted really to the manufacturers and to what we're calling hot topics in manufacturing. So we kind of did a little pool of our manufacturing community and said, okay, what do you want? What should we be talking about at a manufacturing conference? And it was a pretty quick consensus on just a few issues that they would like to have talked about. So we have a great panel. Very, very pleased to have the panel. Thank you for taking your time to talk with us this morning. You'll find one of these little pieces of paper. Either you have one or at the end of one of the rows or whatever. And this is how you're going to let us know what you want to hear more of. Obviously, in 10 minutes, we can't do a whole lot in terms of just an awareness of the issue. And so we'd like to bring some of these speakers back for more involved workshops. So this little sheet of paper is going to tell us what you'd like to see. And you can check more than one. You can check all 5 if you want. But what do you want to see more of so that in the future months we can bring some of these folks back with us. Okay? I'll introduce our panel. Their bios are here in the program, so I'm not going to go through the bios of each person. But we have Dr. Misty Blowers from the Air Force Research Laboratory. Tim will be coming. Tim Haney from Cooperstown Bat Company. Jeff Lewis from CADimensions, and if you didn't see their display up there, they had a nice little 3D printer. Printing really was very popular with the kids, watching the little 3D printer working. So that was a great display. And then we have Devin Morgan from Knull PC, intellectual property firm, and then Dave Palazzoli, is at Mohawk Valley Applied Technologies. Okay, so each of the speakers will spend 10 minutes, and I'm going to probably have to cut them off pretty much after 10 minutes, and then we'll have 5 minutes for questions. Okay, we can just go right in order. Let's see. Oops, wrong. Let me get it here. Here we go.
Okay, thank you.
Okay.
Well, thank you very much for inviting me. It's an honor to be here. I'm from the Air Force Research Laboratory in Rome, New York. A little bit about my background. I worked for about 5 years as a chemical process engineer, and then I went back to school because I was really driven by what people were doing in artificial intelligence and industrial systems. So I went back to school for a master's degree in computer science, and then went to work for the Air Force, where I've been working for a computer scientist, and they actually paid for me to go back for my PhD. So I did a lot more work on in exploring security in industrial processes since I've been there. So I'm going to talk to you a little bit about the emphasis of this is going to be on cybersecurity, but also in general about event detection in the manufacturing settings. So the bottom line up front, we use this in the military quite a bit. Sorry for the military reference here. But undesirable events in industrial control systems can be result in off-grade product or process downtimes. So A lot of the times, these events are attributed to suboptimal operating conditions. They may be attributed to variations in the process itself. There's lots of reasons why they can happen, but one of the scariest things that's emerged recent years is with cybersecurity attacks and the effects that they might have on the industrial process itself. So we have explored different tools within the DoD. I work with different agencies like Department of Homeland Security and Department of Energy, and we've discovered that manufacturing facilities, it's in their best interest to really have a software type of monitoring system to be able to help them prediction in general for industrial downtimes or maybe off-grade production, but also when it comes to security in your facility. So the motivation here, there's numerous cyber incidents in industrial control systems. Not all of these are traditionally thought of as cyber incidents. Remote access software left enabled. This was an incident where a vendor of the control systems was actually looking into a manufacturing facility's process, looking to see if everything was running as it should, and they left that portal open. So when they leave a portal like that open, it makes you vulnerable to cyber attack. There's been incidents where hackers have hacked into SCADA systems. There's one incident where they actually held a gasoline pipeline ransom and told that the owners of that pipeline that they needed to pay them a certain amount of money or they were going to stop being able to transport their product. So just kind of think about that in your manufacturing facility. What if someone actually hacked into your process, took your manufacturing facility down, and told you to pay a certain amount in ransom in order to let it go back up? Of course, the most recent years, we've heard a lot about Stuxnet, the worm, and I'm going to spend a little bit of time talking about Stuxnet and what that actually meant globally. So to carry out an attack like Stuxnet, the creators of the Stuxnet virus needed to have a lot of information about the particular target that they were going after. This meant that they probably were resident on the system for a period of time. They had some modeling and simulations tools. They probably even developed their own pilot plan. So this was a very sophisticated attack. But it got on the system with someone accessing the facility just through a USB drive. They put it into the process itself, into the computer itself. And then it was triggered when the particular facility changed its operating conditions. So it actually sat resident for about 2 years undetected. And it took down the entire facility. And after the fact, they had someone at the mill take a computer that had been connected to that system home and plug it in. And then it hit the internet and it went viral. And it ended up reaching unintended targets worldwide. So that's what you're kind of seeing here in terms of country and infected computers. These were other countries that were infected by this virus, which at that point was a worm that traveled globally. So when you're looking at your manufacturing process, it's important to consider that variability is an inherent vulnerability. It's important to baseline your industrial process to make sure that you can reduce variability as much as possible, because when it comes to event prediction, it's going to be more difficult to predict certain events of interest if you have a lot of variability in your process in the first place. Industrial databases, actually mining the information out of that wealth of data that you have available to you is a very challenging process. You have data that comes from the plant information itself. SCADA is a little bit of a different beast than typical industrial control processes. There's challenges with SCADA systems that are very different. Operator logs tend to be text-based, so you need to be able to have a system to be able to digest that data along with the continuous measurements that you're getting off the sensors from the different points across that manufacturing plant. You have offline quality control measures, and you also have a video in different places across your manufacturing facility. And video surveillance is actually a very underutilized sensor. that we find in these facilities. There's a lot of challenges in understanding the data, which it's important to spend some upfront time in really digesting what you have available to you when you're going to be able to, in order to be able to predict events with a monitoring tool like this. So these behavior-based event detection systems for industrial facilities can really be of benefit to a manufacturing facility. We could, if any of you are interested in contacting me, we could talk a little bit more about some more cyber incidents that have occurred. You can also refer to a repository for industrial security incidents. If you Google RISI, you'll see that there's some databases that exist out there that really collect all this information, and it's an important thing to take a look at. So software analysis in combination with advanced hardware have the potential to vastly improve the defense of the U.S. and coalition partner industrial infrastructures. And I'll take any questions when we get to the panel discussions. Thank you.
Okay, we can do questions now if you'd like. So, do you have any questions?
Go ahead.
Maybe everybody can hear me here, but talk a little bit, if you would, about the types, the various types of industrial processes. You mentioned some sort of continuous flow processes. I think many of the people in the room are probably involved in CNC type machining, processes that are pretty much locally controlled. What sorts of variations are there in the threats for those types of systems?
So I'll turn this on so you guys can hear me a little bit better. So just internally to a facility like that, without having any concern about outside people hacking into your process, you have to be concerned with changes and shifts from one team of operators to another. It's important to be aware of that if there's any either unintentional or intentional insider threats. We've seen situations where operators, when they're bored, they actually bring in their Xbox or their PlayStations and they actually hook it into the computer, and then you have a access point for someone to actually get into your system. We've seen a lot of situations just in the manufacturing facility itself. You need to be concerned more nowadays than ever before about making sure the readouts that the operators are looking at on their controls in their control room are accurate. There's a lot of situations where, in my experience, where you walk in and you talk to the operators and they say, oh yeah, that sensor doesn't work, but we just kind of know that and we just go with it. Calibration of equipment is another big issue that I saw. People just don't always calibrate their equipment. They think that it's not necessary to do it as often as the suppliers might recommend. So I think that that's really important. There's a whole wealth of things that we could talk about in terms of concerns if someone was to hack into your system and the effects that they could have. But that would be a whole nother discussion. So did I answer your question? Is there anything else? Okay.
Any other questions?
Hi, Charlotte.
So how are people dealing with these problems right now?
So currently, with my experience in the manufacturing facilities that I have seen, there tends to be a lot of local solutions that the plant engineers tend to come up with. Some of them develop their own spreadsheets that are linked to the plant information system, and they will flag the engineers when things have gone outside the threshold bounds. So they're really doing a single point observation at that particular point for different control loops across that process. And when you're looking to be able to detect an event that is more serious, you're really going to want to consider multi-point observations, and you're really going to want to consider some of the offline measures and some of the data that you would be able to pull in from other sources. Anything else?
Any other questions? Great. All right. Thanks a lot, Misty. Really appreciate that.
Thanks.
Okay, next up we have Tim Haney, who is with Cooperstown Bat Company. Okay. And
You want me to stand up there?
yeah, please. And you can just advance your slides if you need to there.
Okay,
Okay.
perfect. My name's Tim. I'm owner and operator of Cooperstown Bat Company since 2008. When we first started doing, when I first took over the Bat Company, we didn't really manufacture any of our own products. So we took it upon ourselves to make it a goal that not only did we want all of our products made in the U.S., but we wanted our products made with machines that were made in the U.S. And it's really not that easy, as you'll find if you try to step into this kind of arena. It's just it's difficult to in some places to be able to find the machinery that does what you want it to do, or parts of your pieces or pieces of your parts that you can't find in the U.S. So basically what we're discussing is more just trying to make an effort into consciously thinking about being made in the U.S. It's easy for us just because baseball is America's national pastime, so you just kind of naturally associate the U.S. and American made with baseball. Luke Stark there he plays in the Pecos League down in Texas. He's from upstate New York. He went to Ithaca College. If your raw product comes from where you live, then why send it elsewhere to be altered? All of our raw product comes from upstate New York. We use maple, ash, yellow birch. We produce bats for major leaguers as well as minor leaguers and commemorative bats and so on and so forth. It's just a matter of why send it elsewhere, I guess, is what we basically are trying to say. The lathes, they're needed to keep our company turning as well as theirs. The bat industry, the wood turning industry, is highly, the lathes are basically, they concentrate on production lathes out of Germany, out of Italy. We had to really search. This was one thing that it took me a long time to figure out, finding the right equipment. The lathes are from Warren, Pennsylvania, and they're all custom to us. So the people out there, if you're really interested in trying to make your products made with machines that are made in the U.S., then it can be done, and they're really willing to work with you. And it's nice because I'm kind of like a test pilot for a lot of places, and it just makes it a little easier to be able to have that one-on-one contact with them. You can call them right up. They're always pretty close to the same time zone. Our products, and like I was saying, all of our products we try to make in-house, and slowly we've been able to do that. Right now, about maybe 5% of what we make is made out of our own facility. We turn about 30,000 bats a year, and along with that, we do bat furniture, we do bat racks. We have our smallest rack is about the only thing that's made overseas. And not for lack of trying, you can call 1,000 companies in the U.S. and a lot of them don't. Somebody will figure out that there's a week of time that they have in February that they could make my little pieces, but slowly, as I've been doing this since 2008, it's the more you call them, the more they're willing. The closer we get, the farther along we are, because you're finding that it's hard to get stuff overseas anyways. Employ the people that live around you. If you have U.S. workers, obviously it's U.S. made. It's always good to have young minds in your company. It's a huge benefit. Not a lot of our products are sold. We sell a lot in Cooperstown, but we sell worldwide. But not a lot are sold to the local community, but being an active part in the local community really brings those good workers into our establishment. So as long as we stay proactive with getting out and reaching out to the community that we live in or that the company resides in, it makes it nice. We always seem to get that back tenfold when it comes to needing, we have people knocking down our doors to try to work for us. And then my last slide is basically just, this is a near and dear to me, and it's hard to find because they have a lot of things for solar energy, and renewable energy is kind of a thing. So I saved, let's say just in our factory location, I saved $6,000 in fuel oil when I went to the bioburner. We burn all of our waste, so 2/3 of every billet that we turn goes into the sawdust bin. I kept thinking, why am I getting rid of this? So we actually started, and that's the other thing, the bioburner is made in Kentucky. It's the first UL listed piece of equipment that can actually go into your basement and heat with corn or wood pellets. So our key is to be able to at least think about your waste, and if that can help with dependency on other things from outside the area. We have a lot of wood in upstate New York that can be used for good uses that we just let go to waste. So that's kind of my little presentation.
Okay, thanks, thanks, Tim. And any questions? Stay right there, Tim. We're gonna have some questions for you. Any questions for Tim?
Yeah.
I just wondering, with the ash under siege, how are you gonna? What's your projection for that?
It's for us about out of that 30,000 bats that we turn right now. I would say that maybe 10% of that is ash. So we're heavy into maple already, anyways. The reason maple is so good for us is not only do we turn playing bats, but we turn commemorative bats as well. So we started out on the commemorative side and went to the playing side. So if you know anything about wood, relative density on maple is much higher than ash. So there's a lot less pieces of maple that are actually manufactured that can be used for playing bats because they're too heavy. And it's more just based on weight than anything. Ash is a great wood to use. And right now, we don't see the effects of the borer beetle for us. I don't think they've quarantined Otsego County down yet, but there's so many ash trees out there, and so many people are cutting it. Right now, we're being flooded with ash, and they're trying to give it away, to me anyways, and I don't know how that all's going to play. Nobody's really answered the question for me whether or not they only attack the mature trees. So what's happening in Michigan where 15 years ago the borer beetle first started? So I was curious. Nobody's answered whether or not the ash is growing still, or if it's wiping out the whole species.
Okay, I have a couple more questions over here.
How many, is this on?
Yeah.
How many U.S. baseball bat manufacturers are there making wooden bats? And do you see the amount of, do you see your production increasing as more and more leagues start to switch over? I know American Legion is starting to switch over to wooden bats. Are you starting to see the wood trend start?
Yes, very much so. This year was the first year for New York State being all wood, so it really played a huge role in where we surpassed our bat total production for last year. We passed that in August, the beginning of August this year, which was great for us. We turn a lot of bats for other companies as well, so like Alomar Baseball, all their bats are turned in Cooperstown. We do legacy bats out of North Carolina, so we turn a lot of name brands as well, but we turn them in our facility. There's so much detail that has to go into a Major League Baseball bat that once companies first start figuring out, or they sign up to be MLB licensed, they usually have a large amount of money, so it allows them to get licensed easily, but then after that they fall by the wayside because the production side of it, the manufacturing of baseball bats, isn't easy because there's so many variables that go into every piece of wood. You know, the weights, the models, you got to have all the pieces match up. And if you don't do a large enough production, you'll never get those weights to match up. So it's difficult. All of our wood comes from the Northeast, and all of our wood is from hand split. So we basically do it the old school way of making bats by splitting the log rather than sawing the log. So, and there's about 39 bat companies right now that are MLB licensed for on-field use. And I think 2 of those are from out of country, like Mine Bats is out of Italy, and they just got their Italian beechwood approved. So there's 4 or 5 different woods that are available for us to make our bats out of: Italian beech, American elm, yellow birch, ash, and maple. So, but 39, but there's other bat companies that are not licensed. And we are probably like, Rawlings turns about more in a month than we turn in a year. So.
How long has the transition taken you to be American made?
To be American made, well, let's just say when you start from scratch, it's pretty easy to get the manufacturing side all US made, but we had about, in 2008, so basically right now all of our lasers come from Arizona, our bioburners from Kentucky, all of our saws are from Pennsylvania, all of our lathes are from Pennsylvania. We drive only Ford vehicles. So it was a goal of ours. We wanted to be all US made. And so I would say that it happened pretty quickly because we didn't have anything to begin with, if that makes sense. So when you start with nothing and you just start and your focus is to be American made, it's pretty easy to be there. It just takes a little longer to get set up, and it's not always the easiest thing to do.
Yes, as a niche manufacturer, do you have on-the-job training? How do you train your bat makers there?
And this goes against everything that's around here, but I'm self-taught in everything that I do, so I don't have a college degree in anything, but I worked as I'm a self-taught graphic designer. So basically I worked as an apprentice more or less, and that's how we do our working at the thing. That's the beauty of the young minds that I was mentioning earlier. Young minds pick things up and find new ways. So if I only was limited to, and I think we're amongst adults, but we have a big dumbass club, and we do this lightheartedly, and it sounds funny, but it's not really. But if you're not willing to make mistakes, then you'll never grow anywhere. So I encourage all the young employees to make sure that if they feel like there's a better way to do it, no harm in trying. Because if we don't, and if we screw something up along the way, then at least we've learned, and then we go back and then we start from scratch again, and then we go, you know what I mean? So, and you get thrown out of the club if you keep making the same mistake over and over again. So you can only be in there if you.
Yeah, I had heard that there's a little bit of a controversy as to whether ash or maple is a better material for bats in terms of ability to hit the ball.
Well,
Can you comment on that?
My wood, I spent like a whole week in Wisconsin last year to just do Major League Baseball wood, and there really is no difference. If I have a density is the same, so relative density is the same. So if I have 3 bats in my hand, they're all the exact same weight, the same length, and the same profile. So basically all their relative densities are the same. Ash, the difference between the 3 woods is ash is very flexible, maple's very rigid, and birch is like right between the 2. So they all work equally well. The reason maple gets a bad rap is because it's done poorly. So like bigger companies, they can't keep up with production if you hand split all your wood. So they saw their wood, and you can easily screw up sawing maple for bat play. That's why you see the big barrels flying off. It's not because of the maple itself, it's because of the way it was processed. So if you only come from splits, you can't like hit them all into the outside of a tree and have it split in 2 because it's impossible. But you can saw through the outside of and right through the log, cross cut it. Splits, when you hit the end, it goes where it goes. And if it doesn't split in half, then obviously that wasn't a good piece of wood. Does that make sense?
Okay, in the interest of time, we need to keep moving forward. Thanks very much, Tim. That's great. And I have to say, probably one of my most prized possessions is a personalized bat from Cooperstown Bat Company that I've had for many years. And so it's really, really personal to me. Okay, next up we have Jeff Lewis.
Hi, I'll try to keep this to 10 minutes, but 3D printing is a pretty interesting topic to talk about. So again, my name is Jeff Lewis. I'm with CADimensions. We're based out of Syracuse, New York. Just to give you an idea, what I'm going to talk about is give you a definition of what is 3D printing, give you a progression of the industry as a whole, where it's come from, where it's going, and then talk a little bit about some of the advanced manufacturing applications that begin to be developed over time. So what is 3D printing? 3D printing is the direct fabrication of parts from 3D CAD software. So the universal file for 3D printing is something called an STL file, which comes from any type of 3D CAD software. As an industry, it's about a $2 billion industry since 2012, and they're expecting about 20 to 30% growth through 2020. So the industry is really, really starting to pick up and start growing, even though it's been around for over 20 years, which is something a lot of people don't really realize. Terminology. 3D printing is just one of the names that the industry goes by. I call 3D printing as the commercialized name. It's what you see on CNN. It's what the consumers use. In the industry, we refer to our technology as additive manufacturing because we are actually making parts additively instead of subtractively. We're producing products that are going out to customers or helping manufacturers in their product making. So 3D printing has actually been around since 1980s. So it's been around for over 20 years. And when it first started, the main use for 3D printing was for concept models, for form and fit, for companies to be able to check their designs to make sure it was going to, was the screw going to fit in here or were these two pieces going to slide together. And the reason in the beginning they were limited to this was the materials that they could print out of. They weren't durable enough to be able to go out and field test those. They weren't durable enough to go out and actually be used in a real life situation. As time has gone on, we've really moved into more of functional prototypes, being able to take your design, going out, getting into the user's hands, drop testing it, and seeing how your design is going to hold up in its real life. This is what we call the traditional uses for 3D printing. This is what everyone thinks about when you think about rapid prototype and 3D printing. The companies use it, bring it in-house to do their concept model of functional prototypes. What we've found over the years is that 3D printing or additive manufacturing has a much greater use for companies. So I would say over the last decade, last 10 years, as the materials have improved, as the processes have improved, we've really taken a much larger step into the actual manufacturing process. So not only are we helping companies in their design process where their prototyping work, we're now helping them in their manufacturing realm. And how we're able to do that is companies out there are using 3D printing for both low manufacturing of products, so low volume parts, maybe a few hundred, maybe a couple thousand a year. Companies are using them for jigs and fixtures, for the assembly of their products. This is one of the largest cost savings for companies out there, and it's one of the biggest applications that we talk about that companies ignore, and that is jigs and fixtures. Companies out there who have adapted the idea of using additive manufacturing for jigs and fixtures throughout the facility have been able to save their companies hundreds of thousands of dollars over the course of those years. It's really not something people think about because it's not a cool, what we call a sexy application. It's something that's pretty simple, but it can really benefit a company to be doing that. And then we also have companies out there who started to use it for end-use parts. So actually going into production, whether it's the actual end part itself or a part that's going into an end product. And the final thing that we've gotten into, and this is mainly dealing with a lot of military application, is the support. So being able to support older aircraft as their life has gotten extended and the original tooling for those aircraft no longer exist, companies who make those products are looking to additive manufacturing either to remake that tooling or to actually make the product to keep those aircraft in flight. So what is the additive manufacturing sweet spot when it comes to production or for tooling applications? And what you're talking about low volume, high complexity. So we like parts that are very hard to machine, parts that take maybe 3 or 4 different steps to machine, where with additive manufacturing we can build that all in one piece all at the same time. So we take your 3-step process down to 1. The thing about additive manufacturing, which is probably the biggest barrier for us to get over, is you don't have to follow the rules of traditional design constraints. You can manufacture anything you want, which is really what is a big barrier for companies who are trying to adapt this technology. So again, we're talking about parts that have high complexity and have low volumes, a few hundred to a few thousand pieces. My next couple slides are going to be what I chose as some of the most interesting applications that have been developed over time for this industry. One of the first ones is using one of Stratasys' technology, which is called PolyJet, which is an inkjet-based technology. And they're actually using this to create short-run injection molds. So they've been able to use this material, print it out in a few hours, take their design and shoot it with the real thermoplastic that they like, polypropylenes, different type of nylons, nylon-filled materials. This has actually been an application that's been around for about 2 years. It's been very popular over in Germany with some early adopter companies. And we're seeing a lot of companies in the United States who are starting to adopt this idea and bring it in-house to be able to do some of their short-run molding applications. The next application is actually metal forming. When I first saw this one, I thought, what do you mean? Who would ever thought that would be forming metal over plastic? So we're actually using what we call our FDM process, which is fused deposition modeling, which prints in thermoplastics. And companies out there like the U.S. Naval Air Systems, Piper Aircraft, are actually using this process to create all their tooling for the metal forming. Because they have low volumes, few hundred pieces, going out and getting a part machined for that tooling is expensive and time consuming. When they're bringing in additive manufacturing, they're able to cut down on that time and cost of that tooling. So you can see some of the parts that they've done. That's an example of the thermoplastic piece there and the metal piece that was formed, rubber pad pressing, and then stretch form pressing. Another application would be thermoforming tools. So printing with our FDM process is actually a porous process where people actually can pull a vacuum through the tool without ever drilling and tapping. So short run production pieces where companies only need 5, 10, 15 pieces. We worked with a company up in the Albany area called Kintz Plastics. And the reason they were interested in getting in this because they were tired of turning down business that was 20 to 50 pieces. He didn't want to turn down that business anymore, so he wanted to find a way that he could make those customers worthwhile. And the last application I'll talk about is soluble cores. So with our FDM process, we actually print in soluble support material. And what companies are doing is they're actually just printing in that soluble support material, and then they're wrapping it in a carbon fiber or a resin, curing it, and then they're able to wash out that support material in a hot water agitation detergent bath. This part here is actually a part for a Joe Gibbs Racing. If you're into NASCAR, they use one of the Stratasys systems for all of their intake manifold designs. So what's allowed them to do is in between races when they need to make changes, they can quickly make those designs and design changes, test them in a day or 2 instead of 3 weeks down the road. So that is my quick glimpse into 3D printing. There's a lot more going on. The industry is changing every day with new companies, new materials, and new machines out there. And I'll open it up to questions.
Right. Maybe you can tell us a little bit more about 3D printing with metal.
Okay. Yeah, there is 3D printing with metal. It's been out there for a few years. It's still, I would say, in its beginning stages. There is a lot of post-processing that goes to it. The systems are very expensive, the materials are very expensive, and you still actually need subtractive methods to finish the parts. So we have several customers who have metal systems, and he said a lot of people don't understand is the machine might cost you $1 million, but you also need $250,000 in CNC tooling to be able to finish the parts to send out the end product. But there is a lot of interest in metal pieces, and there's several companies out there that are making them. Most of them are German companies.
Okay, could you tell us a little bit about your machines, the accuracy as far as the thickness of the layers you split into, and also your XY accuracies for, I know you got a range of machines probably, but.
Yeah, we have over 20 systems that are based on 2 different technologies. One is called FDM, which is probably what everyone's most familiar with. That's where you see the MakerBots in the consumer markets. Those are all FDM-based systems. For those systems, our layer thickness would range between 5 thousandths of an inch to 13 thousandths of an inch, and the resolution, depending on the machine, will range from 3 thou across X and Y up to 10 thou. So the higher-end systems print the thinner layers and are the more accurate systems. On the other side of the fence, we have what we call our polyjet technology, which is the jetting of a resin that's cured with a UV light. They print in either 16 or 30 micron layers, so much, much thinner, and the accuracies are about relatively the same, between 3 and 8 thou across the build platform.
Other questions?
I was wondering if the manufacturing process along the way, I don't even know if this is on, through either individual parts or maybe if you have multiple machines, if it would benefit from something like Dr. Blauer's event detection software or something like that.
Can you,
What do you do for security?
for security? Well, the systems are all sit on a company's network, so the systems actually think like they're an HP copy printer. So whatever company has in their own security stuff would be what would be the security of the systems. I know out at Stratasys, due to ITAR regulations, they have locked rooms and all that kind of stuff. But for security of the systems would be whatever the security of your network is, because that's where the printers sit.
Any other questions? Okay, thank you very much, Jeff.
Yep.
Okay.
All right, well, I've clearly set myself up for all sorts of great lawyer Luddite jokes because I don't have a PowerPoint. I have paper handouts. But really, no, I'm a technology attorney, I swear. So I'm a patent attorney with Knull PC out of Cooperstown. Background in engineering, then went to law school, and then have done wide variety of technologies. Started mostly with software and internet-related stuff, but then I ended up in the disk drive industry, which, if you know anything about disk drives, has everything from chemistry to nanoscale, control systems, mechanics, you name it, it's in a disk drive. And so that was a great education. And now I'm back out in private practice and helping people with securing patents, but then also a lot of licensing transactions. Just finishing up a $5 million patent portfolio deal this week. And I've handled transactions everything from basically free with back-end royalty to $20,000, $30,000 for a patent license to obviously $5 million portfolio. So there's a pretty wide range of things that are done in patent licensing. And sort of the point of my talk is really to talk about, as a manufacturing company, as a small manufacturing company, how can you use technology in licensing to grow and to expand your innovation and your capabilities. I think as a starting position, I think most small manufacturers have figured out that some level of innovation is required, right? It's not a nice to have, it's a need to have. Global marketplace, if you're solely going to compete on cost, you're probably going to lose. And so coming up with the next new thing, an edge that is competitive either for your direct customers or for your customers' customers. Those are really where your advantage lies, as well as innovation that's actually within your internal process, and actually does make you more efficient or have a different capability than your direct competitors do. So innovation is key, but most small manufacturers aren't really set up for pure research and development. Depending on the type of manufacturing, if you're a straight up product company, most of what you're doing is repetition of your core products and maybe minor variations thereon, and tend to be about volumes and efficiencies. If you're more in custom manufacturing, you still tend to have your skill set related mostly to how do I use my line, my facilities, my staff to complete kind of the project at hand. And so that tends to be more product and process engineering, not kind of pure R&D. The good news about this is it's all capabilities that are are near to things that you do. It's not that your engineers can't do it, and it's not even necessarily that your techs don't have great ideas for how to improve, products or processes. It's just not necessarily something that you've done a lot of previously. And so one of the ideas behind in-licensing a technology is really to plant a seed, something new that your company can then kind of take and run with, and can be almost a pilot project for your own internal R&D or technology development capabilities. And so, the classic example of this is that you find out from a local university, a local government lab, that they have a technology that solves a problem that you've already seen among your customers, or fits in well with your existing product portfolio. You now have the opportunity to go to that lab and first of all learn from their experts, why did they come up with this, what do they think its capabilities are, how far have they taken it, and bring that back to your company and your resources and say, all right, now talking to my team, my engineers, my marketing and sales guys, and what they know from our customers and our markets, what can you do with this? Does this look like a good fit for solving a problem that we have out there? And can we build a saleable product around it? And frequently the answer to that is going to be yes. Now, it's not without work, it's not without risk. And so, like all innovation, I think you have to go into it with eyes wide open, that there's going to be some missteps. You're going to have to be ready to iterate, to try something new, and it may work, it may not work, kind of keep it going. But again, the nice thing about in-licensing is frequently you can negotiate a deal that says, hey, I'm going to bring this in-house, I'm going to work with it for a little while, and I'm not going to pay a lot for that privilege. I'm going to pay on the back end if we get to a point where we are producing a product in volume and making money. Absolutely, I'll share the wealth. I understand this technology is coming out of some other source. But if it doesn't go anywhere, if I run into roadblocks, if I can't get it off the ground, then I got to be able to give it back. And that was actually, I'll say, it took the tech transfer guys in a lot of the university and government labs a little while to get comfortable with this idea. That just because your researcher had a great idea, it didn't necessarily mean there was a great commercial product out there that was going to be executed on it. And so where there was a time, I think particularly back in the 80s and even into the into the 90s, where you had licensing offices looking for big fat upfront fees, a lot of that's gone away, and a lot more has gone to this idea of, all right, we'll give you a shot with it, and yeah, there are going to be some benchmarks you've got to hit, but if you hit those, then great. It's relatively low cost, kind of upfront. And the great thing about this is it's a way for you as a company to leverage what you already know, what you already have, whether that be people, whether that be market knowledge, whether that be customer contacts. Take those things that you already have and do well, and now you can mate that with some pure technology coming out of a lab. Or even another company. One of the other opportunities that I talk a lot to people about is the fact that for large companies, something that is a $10 million product line, they don't care. That's not interesting. That's not even a real opportunity on their radar. Where for your company, that might be huge. And so there are opportunities also out there to partner with existing companies who maybe have some technologies that are either outside their core or are so niche, help such a small segment of customers that they're not really all that interested in it themselves. So that's kind of the big idea behind in-licensing and kind of hooking up with technology developers and trying to get their technologies out into the marketplace. There is a handout, incidentally, which kind of goes through this in bullet form that will kind of circulate and you can take with you. But are there any questions?
Real estate closings usually take 60 days. How often do your transactions usually take?
All right, well, I will just say, the patent deal I just closed took 4 years. But it's not a good example. I mean, this has just been, we've been through like 3 teams. There's been a bunch of turnover, multiple mergers among the companies involved in the transaction. I mean, it's been a nightmare. On the other side of it, I have had a transaction, and it was even with a university involved, that was about 60 days. And so a lot of it depends on just the motivation and staffing levels of all the people involved. A lot of universities can do pretty quick things. It can also depend a lot on what the size of the deal is and what the nature of the technology is. And this is all, and at the end of the day, it's all people stuff, right? So there are labs out there that are notoriously awful to deal with. And there are labs out there where, you almost wonder whether anybody's paying attention because they sign some things that you're like, really? Huh. So it is all over the map, and so I don't know there's a good rule of thumb. I would say there's no reason why you shouldn't be able to get a license done in 30 to 60 days if people are really working on it. The problem that you run into is if you've got anyone involved who doesn't really care and is willing to just let it sit on their desk or sees it as too risky of a deal, and so is really kind of waiting for people to slow it down and hopefully kill it, then that can be a problem. But I tell people about transactions of all kinds, notwithstanding my 4-year deal that did actually finish. Time is the enemy of deals. And the longer something stretches out, and I think it's particularly true when you're talking about big companies and large institutions, the more time somebody languishes, the more likely it is that your champion's sort of interest wanes and they're no longer your champion, and or there's a change in someone else in the organization that influences the willingness to really finish the deal. And so I would say, in fact, shoot for 30 to 60 days, because if it goes much longer than that, you're actually adding risk. Other questions?
So another question back here.
Do you work with any situations in which there could be multiple owners, governments, NGOs, also probably the business sector too?
Right.
Different states, different countries involved?
Absolutely. I mean, so that's kind of, in some ways, that's the challenge of intellectual property, is that it is kind of without boundaries. And on the good side, as we've gotten into a lot more open collaboration models, you do see a lot more stuff that has multiple kind of hands going into it. I always counsel that if you can simplify ownership along the way, do. Because if you are going to have to coordinate with 5 organizations every time a decision needs to be made about something, it really slows things down, and it can kill things. Even the transaction I was just working on involved a group of companies buying patents from another group of companies. And so one of the reasons why this deal took so long is just the sheer coordination factors. Like, we'd get everybody aligned in one organization, and then in some other organization, somebody would leave, or there'd be a shakeup or a merger or something. And it was basically like resetting the process. And so every one of those sort of sets of approvals you have to go through are horrible. And actually, when I was counseling them even on sort of the ongoing maintenance of the portfolio and stuff, one of the things we discussed is, do you really want to end up joint owners of this IP? When I was in-house, it was one of the things that drove me crazy. We had a couple of jointly owned portfolios, and every time a maintenance fee decision came up, I had to get 3 other people on the phone to say, so are we going to pay this or not? And from an efficiency standpoint, it was ridiculous. So it can be done. People do it as much as you can to push towards simplicity. It's better. Typically, the government does not want to be the owner. I mean, in my experience, there's a bunch of things that the government doesn't really want. One of them is owning a lot of intellectual property. The other thing is responsibility for lawsuits. If they can do anything to say, hey, if somebody else is going to infringe this intellectual property, you all fight about it. I don't want to hear about it unless it involves you writing me a check. You know, and I will say a lot of the large organizations involved in these transactions, that's the view that they're sort of taking with them. It's like, hey, we would love for somebody else to take this stuff and run with it. We don't want the liability. We don't want the lawsuits. We do want the upside. And so, you know, that's a lot of what you've got to negotiate. A lot of governments, you know, do have some rights. It's one of the things that I think scares people a lot about working with government laboratories sometimes. If you look at sort of statutorily what a you know, government-funded patent, you know, what the government's rights are, they're like, oh, they've got march-in rights. They can show up and take my patent whenever they want. Well, but they don't. I mean, they don't really want to. That's almost like a war power kind of level thing. It doesn't get triggered normally. So, you know, if the government's one of the parties involved, usually they're looking to get out of it. Yep.
Okay. Thanks, Devin. I think that takes care of that. Thank you very much. Good job. And then finally we have Dave. And I'll see if we can get up his presentation. Yeah. No, you got plenty of time. So.
Well, no, it's just that it makes more sense to do that.
Okay.
So if you just crack it up, I'm going about slide 25. See if that'll get me where I want to be. No, go up a little bit. 24, 23, 22. Keep going. Keep going. Keep going. Oh, crap, you're going the wrong direction. Keep going. Keep going. Okay, there you go. Start there.
Yeah. All right.
Where's my control?
Your control's there. And just to go forward, just there.
Okay, thank you. Wait, just a second. Everybody, is this a good-looking guy? Thanks, Mark.
Kind of the gray hair beard kind of looks the same.
Doing a wonderful job, too. I mean, this is not easy. I really like to thank the college for the opportunity and thank all our speakers. I'd like to reference a couple things before I start. We heard some interesting things here today. Avoiding undesirable events. I mean, of course, who wouldn't want to do that? Who thought they were going to meet Batman today? I mean, really. But something he said. Why are we manufacturing in New York? Because that's where the raw materials are. Upstate New York is a wealth of raw materials. You know, Chobani is another example of that. Talking about prototypes. He mentioned NASCAR. Tim, right? Jeff, right? I'm sorry, Jeff mentioned NASCAR. Here's an organization where technology changes momentarily. They finish a race and they want to develop something that day to test tomorrow. And here's the capability. How can you go against that? You know, and then we heard from Devin about intellectual property. It's something I talk about all the time. Anybody here want to tell me where the technology that created the CD was invented? Romeo. Thank you very much. 1955. You win a lot of bets, especially with people from Sanyo. So going forward, what do I want to talk about? I'm talking about the regulatory issues in New York State and how they affect manufacturing. Simply put, if you're a manufacturer in New York State, the state holds you responsible for what's going up the stack, or what's going down the drain, or what's going out with the trash. What do you want to avoid? You want to avoid those undesirable events. You know, you want to avoid injury to people. You want to avoid environmental dangers. You want to avoid problems with the facilities. And obviously, you want to you're interested in business continuation. All right, so these regulations exist, and we have to follow them. So I could simply say, get the rule book, follow the rules. Okay, I don't recommend the rule book anymore. Get to know your New York State DEC website intimately. Start trusting your New York State DEC representatives. They are actually here to help you. I can't believe I just said that. Isn't that one of the 3 great lies? Okay? You see the slide that's sitting up here. Don't wait, start tomorrow morning. What am I saying? You know there's regulatory rules. You know those rules are out there. You know they apply to you. You're a manufacturer, or you're planning on being a manufacturer. All right? You know you have to meet the regulations. The time to start is with everything else. Pay attention to the regs from the beginning. One of the biggest things I do as a consultant is help pull people's feet out of the fire, and their feet wouldn't be that close to the fire if they didn't wait till the last minute, or didn't wait till a regulatory agency came to them and said, what are you doing here? What's going on here? Instead of that, you know, they found out what responsibilities they have, and they kind of move forward from there. And they don't wait till pull the all-nighter. I know it's a popular thing to do in college, but it really stinks when you're trying to do it with a regulatory agency. So, as I said, I made a couple notes while the other speakers were talking. In this area, now I'm a child of the 50s. You know, in fact, I turned 65. I was born in 1949. And in my history in this area, we have had a lake you can't swim in. You can't eat the fish. All right, anybody know where that is? It's out near Syracuse. All right. We've had 3 rivers catch fire in a city in Pennsylvania, Pittsburgh. We've had Love Canal, the story of Love Canal out near Buffalo. Again, we have cities where you couldn't breathe the air. The major metropolitan areas in this country, in the 60s, you couldn't breathe. China's having that problem now. Here in Utica, we had a company pouring chemicals in a hole in their backyard, and nobody knew it until it started oozing into the cellars of the houses across the street. All right? So these rules are necessary. These rules exist because they are necessary. And some of the things you do, we talked about intellectual property. Part of the fun of having these rules is learning how to work with them, okay? California developed a green chemistry regulation in 2006. What are they saying? They're saying the chemistry you're using now, figure out how to make it safer, all right? Figure out how to make your processes safer. Something was said to me out there earlier this morning. You know, we added engineers and it streamlined our work. We found a lot of things going better because we added technical people. All right? If you have engineers working on process safety, add engineers working on making the process greener, it works for you. What do you want to do? You want to transition from the dangerous things to the more safer alternatives. A lot of the metalworking companies in this area used to use trichloroethylene as a degreaser and a cleaner. Who misses it? Nobody uses it anymore. Why? It was really dangerous. It was dangerous to breathe. It was dangerous to have on your skin. It was a very dangerous chemical, but it did a great job cleaning metal. The rules made it so hard to use this stuff that manufacturers started looking for something better and safer. Here it is a few years later, nobody uses it, okay? You can green these things up. You can improve your processes and follow the rules. All right, you want those priorities. You know, again, we would talk about, you don't want any injury to your people. You don't want to injure the environment. You're responsible for what's going up the stack. You're responsible for what's going down the drain or out with the trash. All right? Protect your people, streamlining, you notice your production and your progress goes very well. You talk about eliminating dangerous things. You talk about substituting less dangerous or safer products for the dangerous components. You talk about engineering controls. You know, engineering controls, changing the workplace to keep the people safer. Again, all the regulations that are involved in manufacturing in New York State and in a lot of our states, the more responsible ones, are involved with protecting the people and protecting the environment. It's your responsibility to make it profitable, you know, and it's a win-win. Administratively, the company has to create rules. and then make sure their employees follow the rules. So you have that administrative part of it as well. And if nothing else, at least teaching people how to keep themselves protected while working with the items. But going back, the best thing to do, find chemical substitutions. It's usually about chemistry. When we're talking about regulations, everything breaks down to chemistry. You're machining metal, but you're machining metal, dust is being released in the air. The elements of the metal are very dangerous to breathe. What do? You know, how do you control that? It's always about chemistry. How do you find out about chemistry? You read your safety data sheets. You don't want the regulatory people coming in the door and telling you your business. You know, you're responsible to do it right the first time. And, you know, I've had people say to me, well, you know, how do I know what they're doing out on the floor? I think you're supposed to know. I think if you're in charge of a process or in charge of a facility or in charge of a product, it's your business to know. And, you know, I can't say any more than that. The rules can be difficult if you choose not to follow them or if you choose to wait until the regulatory agency is at the door, and it's safety rules or environmental rules. But if you make them part of your process going forward, the process safety is as big a part of your process as profit and everything else, you'll find that when they come to your door with a little tweaking, you're in good shape. I was also warned out there to be careful what I say in here because there's students in here and you might scare off a potential, you know, golden nugget type of person by giving them things to worry about. I don't think I'm up here to give you things to worry about. I'm just really up here to remind you that our responsibility in New York State is to keep it as nice as it is. I climbed a mountain a couple of weeks ago, and the Adirondacks is full of beautiful scenery, and that place was spotless. It was pristine. And they had a lot of rules posted on the way up about the conduct. You followed the rules, and you kept the place nice. And I think New York State following the rules is going to keep the place nice. That's all I want to say.
Question for Dave. What was the Algonquin?
Oh, Algonquin. Right. They said it was the hardest one, so I said start there.
Other questions?
I have a frequently asked question. What about the other states and countries that are kicking our butts because they take our business because they don't have those rules? Hear it all the time. I did a radio show on Tuesday, and I was asked that question. They're not getting away with anything. Okay, you move your company there this year, and wow, this is so much easier. And then 5 years down the road, they discover, hey, we need regulatory rules. They're going to come up with rules that we haven't thought of yet because they're going to be, you know, trying to catch up. There's no advantage. China's going through it right now. Their people can't eat, they can't drink, and they can't breathe the air. They're going through it already. It doesn't get easier. They're just kicking the can down the road.
What are your thoughts on Assemblyman Brindisi's career to technologies pathway?
Terrific. Terrific. That was great to hear. A lot of times when I hear politicians speak, they speak in the first person a lot. You know, I'm doing this or I'm planning that. But he did a great job. And what he's talking about, really, you know, one of the things I see when I'm in manufacturing facilities is permanent signs painted on the front lawn. We need people. And to have people graduating that can walk into that environment with some knowledge, you know. And I love the idea of the apprenticeship that Tim was talking about. I think Assemblyman Brindisi is right on the money with that, and I really applaud his efforts.
Okay, any other questions today? All right, can we have applause for Dave, please? All right, let's hear it for all of our panelists. They all did just a wonderful job. I would remind you that there's these little sheets that they're out in the audience. If you don't have one, come get one before you leave the building. And if you want to hear more on any of these topics, please fill out the sheet. You can choose more than one, and we'd be happy to arrange a longer workshop so we can take advantage of their expertise.